today's lesson, we're going to talk about analyzing categorical data. So our two learning targets for today, what I want us to get out of this, is I can display categorical data using pie charts or bar graphs, and I can distinguish between good and bad graphs. So categorical variables, once again, they place individuals into one of several groups or categories. When it comes to displaying this data, the values of the categorical variables are labels for the different categories, and the distribution of the categorical variable lists the count or percent of individuals who fall into each category. Okay, so again, let's just work on some vocabulary. So here's a distribution of bachelor's degrees awarded in 2007 at a particular college. So first of all, the individuals are the different bachelor degrees, okay? So we're talking about placing people into categories based on their degree. So the major is the variable. The values of the variable are the different majors, okay? So being a business major, a social science major, or history major, education, those are the values that the variable is taking, okay? Now it probably feels a little bit strange using the term value to describe that. However, for categorical variables, the values are kind of those groups that they're being put into, okay? Then we have the counts, or sometimes you'll hear them called the frequencies. How often are people in that category? All right. Or the other way you can track the data is as percents or otherwise known as relative frequencies. Now I do want to show you though, okay? So there's two types of bar graphs that you can make. You can make a frequency bar graph or a relative frequency bar graph. So this one right here, okay, this is based on the number of individuals, okay? So this is just a frequency bar graph. Okay, this one is based on the percent of people that had each major. So this is going to be a relative frequency bar graph. And a couple of things I want you to notice about the bar graphs, okay? So first of all, I've given it a title. I've labeled the x-axis and I've labeled the y-axis. All very important things, okay? You absolutely need to make sure you're putting labels everywhere. Title your graph, label the axes. That is part of the whole communication thing that we talked about the other day, but making sure that you're giving all the information possible. Then notice you've appropriately scaled this side here, starting at 0. And then obviously each category just goes up to however many people were in that major. Okay, so I know you've seen bar graphs before. It's not anything earth-shattering for you, but just I wanted to reemphasize those key things you need to show me. Okay, you need to show me title, x-axis, y-axis labels, and then just make sure you're appropriately scaling it, starting at 0, and then make sure that you do the appropriate heights for each bar. Now, the thing that I think is really interesting is notice the shape of these two graphs, okay? One is a frequency, one is a relative frequency bar graph, but taken from the same data, notice that the shapes are exactly the same. I could overlay these on top of each other. You would have exactly the same graph, okay? The only thing different is one is tracking the count, one is tracking the percent. But notice that does not affect the shape of the graph, okay? Just interesting feature and a good feature to realize that that is what happens. All right, so let's talk about this. Why would it be appropriate to make a pie chart out of this data? Okay, so notice to the right, I have a pie chart. This is the same data we were looking at on that last slide. And we want to know, why is this appropriate? Okay, why is it okay to make a pie chart out of this? Well, the answer is because they make up part of a whole. We're taking a university, a single university, and we're tracking the students in it, what majors that they had. So those different students, they make up the whole of the university. So they come from a single whole, okay? So just keep that in mind, that in order to make a pie chart, you have to be talking about parts of the same whole, and you have to be adding up to 100%, obviously. Now, in terms of the AP test, now they're not going to sit there and make you draw a pie chart, okay? Because that gets really messy because you have to find the angles and all that kind of stuff. So that's not my concern, is if you can make a pie chart. Because quite honestly, likely you're not going to have to. My concern is, do you know how to read the pie chart, okay? So can you associate, like here for business, that 21.5% of people were business degrees, okay, or business majors, I should say. Now, another thing that is kind of a good skill to have, okay, and that can pop up is, let's say we talked about, oh, I don't know how many people there were in here. So let's just say there were 6,000 people, okay? Again, I'm just throwing out this number. Let's say this is 6,000 people that we got this information from, and 21.5% of them are business majors. So what you should also be able to tell me is, if I give you how many people were surveyed, you should be able to tell me, well, that means that, let's see, 6,000 times 0.215, that 1,290 of them were business majors, okay? You take that percent as a decimal, multiply by how many total people there were, that gives you the number of people in each category, okay? So again, just to show you, that is another skill that could show up. All these little things in reading a pie chart. Not making one, but can you read one is my concern. All right, so speaking of data, so here are the percents of 15 to 18-year-olds that own the following personal media devices, according to the Kaiser Family Foundation. So they're talking about cell phones, MP3 players, handheld video, game players, laptops, or portable CD and tape players. Okay? So they want us to represent this data, first of all, as a bar graph, okay? And because it's categorical, that is why we can make a bar graph out of it. Now, I already have mine done, but I want you to sketch in the different bars, okay? So, again, notice, label with device, labeled with how many people. The only thing that this is missing is a title. Okay, so this is going to be devices for 15 to 18-year-olds. Again, always good habit. Check to make sure you're providing labels and a title. And then, of course, just making the bars the appropriate height. Cell phones, 85% of them had cell phones, so the bar should go up to 85%. So notice this one's checking percent, so this would be a relative frequency bar graph, okay? The other thing I should have mentioned before, but it slipped my mind, is I want you to notice bar graphs have gaps between them, okay? So I do want you to make a note of that. In bar graphs, bars don't touch. Okay, make sure you're leaving a space there. That is very important because bar graphs are similar to a different type of graph we're going to cover for quantitative data. Okay, so just make sure you recognize that. Now, making a graph is never going to be the end of our story, okay? Once we make a graph, now we want to see what information that gives us, okay? How does it help us? So, not only are we making this graph, but we also want to describe what we see, all right? So what are we seeing? Well, here I've already labeled out a good description for you. Again, the thing I want you to pay attention to, I've put my answer in full sentences, complete thoughts. Don't give me fragments. Don't just bullet different things that you see. Okay, I want you to analyze thoroughly. Give me full, complete sentences as you're describing your answer to me. So what am I seeing? Well, it appears that a large majority of 15 to 18-year-olds own cell phones and MP3 players. So yeah, the first thing I notice is those two are pretty equal, okay? And they're overwhelmingly more common than anything else, okay? Then I noticed about half as many owned video games and laptops, and then a very small percentage own portable CD or tape players, okay? That would be a good description of what I see, okay? So whenever I give these to you, you should really be writing down as accurately as possible what I have on the board, okay? In a video, that means you can pause it if I'm going too quickly, or in class, make sure you just raise your hand, tell me to stop so you can finish writing. Because again, these examples are modeling good responses. How can I thoroughly give responses, okay? Because that thoroughness is what is going to earn you points on the AP test. All right, so would it be appropriate to make a pie chart of this data? Why or why not? Well, the first thing I notice, those percents add up to over 100, right? So that should tell you absolutely not. A pie chart would not be a good way to model this data. It would not be appropriate since each percent of the table refers to a different device. These are not parts to a whole, okay? So 100% of people could have owned a cell phone, and 100% of people could have owned an MP3 player. These percents are not part of a whole. These percents are just for each individual device, okay? So, and finally, good and bad graphs. So we also have to make sure that we know the features that make good graphs and that make bad graphs. So there's a couple things wrong with these. Okay, so first of all, that first one, if a picture graph has misleading representation of the data because of its area. So here notice this looks absolutely huge compared to that, when the values themselves aren't that different, but our eyes envision the area, and the area is exacerbating the difference between those values in that picture graph, okay? So that's why I usually avoid using anything like that, okay? Just make a bar graph if you want to. Don't make picture graphs. They may be pretty, but they're very, very misleading, okay? The other thing to watch out for is when you're representing this categorical data, make sure you are starting at 0. Okay, for example, here we're starting at 10. Now you may be wondering why that's bad. Well, again, it's exacerbating the difference between these values. It's making the difference between this and this look even greater than it is. Okay? So again, just two very good things to be watching out for. If you're analyzing data, make sure that if you notice some of those things that are wrong with the graph, note those. So they're good comments to have, okay? And you should be having those kinds of thoughts for me. All right, so that is going to be it for today's notes. So once again, thank you for joining me, and then I will see you in class.